Hello everyone, welcome to STEMAC. In our last class, we talked about SPDF orbitals. So, in our last class, we cover up what type of, in what axis those electrons are happen to be present, and how those orbitals look like, and how S orbital look like, P orbital look like, and D and F orbital look like. And today we're gonna talk about the SPDF block elements. And what is this? Those block elements are present in the periodic table, where it is classified in the base of their electron orbital outer valence electron shell. So today we're gonna talk details on the topic, what S orbital block elements are, P orbital block elements, and D F orbital block elements are. And firstly, we're going to talk about S orbital block elements. Here, S block elements, S block elements are present in group 1 and group 2. For group 1, it is alkali metal which is a base configuration, and 2 is alkaline metals. So those are the alkali and alkaline metal for group 1 and 2, and this is for S block elements. So secondly, electron configuration, it occupy the S orbital. So why it gonna be occupy the S orbital, as it is S block elements? So, and why it is X box element, and it is depend on the electron configuration and how many electron present in this orbital at these cases. And it is and it is defined as NS1 and NS2, which means if it has a 1 electron present, so it gonna be 1s1, and if it is a 2 electron present for in the first layer, in the first orbital, so it gonna be 1s2. For second orbital, if it has a, like, this is the first orbital which we learned in our last class, and here is the second orbital. For the second, that the n, here the n gonna be 2, so n 2. So as if it has 4 electrons, so here gonna be another 2, this 2 and 2, total 4 for this, for which has a 4 electron in total in case of S block elements. So which are the elements? They are, for group 1, here is lithium, sodium, potassium, rubidium, cesium, francium, and for group 2, beryllium, magnesium, calcium, strontium, and here rubidium, so radium. So those are the group 1 and 2 element for S block elements. And here for the properties, what are the properties, how they act, how they look like, this is gonna talk about in properties. Everything in this world have some own personalities. Those S block elements have a personalities too. So here we're gonna talk about in these properties. Firstly, highly reactive. They are highly reactive. They are easily, they lose, if in a case of they easily lost electron if there is a nearby electron present which they want to gain, and those all the time, those happen all the time. They easily lose electron, gain electron, and get into combined position. This how they react, and especially that happen for group 1 element. Here lithium, sodium, rubidium, cesium, francium, those elements have this highly reactive configuration in them. In group 1 cases, mostly group 2 also present, but in case of group 1, they mostly show this side of their personality. We're gonna identify all of them as their personality. We all have personality. So here, just imagine S block have a personality, they get into other so easily because they are highly reactive. And good conduct of electricity, they are conductor of electricity, they conduct electricity so easily. Between them, those electrons pass by easily, so that's why this is called good conductor of electricity. And they have low ionization of energy and electronegativity, and those ionization and electronegativity we talk about in the bond class. You can see there and they can form a bond, a strong base. As you know, here we talk about their alkali metals and alkaline metals. So because of their base formity, they are gonna form a strong base. So here they form sodium and sodium hydroxide, which is sodium hydroxide and calcium hydroxide, which is highly a strong base. And that's for S block elements. Next we're gonna talk about P block element, and it is present in the group 13 to 18. Group 13 to 18. So here for in that box 13 to 18, it gonna have the all elements present, and electron configuration for it, we have it occupy p orbitals. So we know the orbitals, as it has just imagine nitrogens, which is 7. It has 7 electrons present. So here in the first orbital we gonna have 2 electron, and in the next orbital we gonna have 4 first, then here the 5th electron present. And for the electron distribution, we have 1 s square, then 2 s square, and then 2p3. And this 2p, in case of p, it never gonna be 1p. So here that for the configuration. And what are the elements? And the elements are non-metals. They are those elements present in the group 13 to 18. They are non-metals: nitrogen, carbon, and oxygen, etc. in case of non-metals. And then it have metalloids, selenium and germanium, and it has metal, aluminum and gallium in case of these elements. So in 13 to 18, for p block elements, it have non-metals, also metalloids and metals. And here for the properties, for p block elements, it shows variable oxidation state. For heavier elements, like those electrons number will increase and its oxidation state varies continuously. And here for the electron negativity increase from left side to right side. From group 13 to 18, it gonna increase that side. And in case of electron negativity cases, from group 13 it gonna have more electron negativity, and in 13 it gonna have less electron negativity than group 18. So here also it has ionization energy increase from left to right, like noble gases it has less reactive. And here for the metals, those metals here present, aluminum and gallium, it gonna have more reactivity. In case of non-metals, it for oxygen and chlorine, for it form covalent bond, and for metalloids it show intermediate states. They show both sides in case of p block elements. Now we're gonna talk about d block element, which is present in group 3 to 12 in that boxes. So here for the electron configuration, it has valence electron occupy d orbital, which is d orbital. That means it has sp,d in their electron configuration. For like iron, which is 26, which gonna have here 1 s square, 2 x square, 2p6. We know as though it has more electrons, so all the p blocks are gonna be completed. 1 s square, 2 s square, 2p6, 3 s square. Now we have 2, 4, 16, 12. 3 s square, 3p6, 4 s square. How many electrons left? 2, 4, 10, 10 and 10. So we have 6 electrons left. So that 6 gonna have 3d6 in this d block. So that's why they are called d block elements. So here, which are the elements? They are mainly they have transition metal like iron, copper, zinc, silver and gold. And they are, what transition mean? They show different type of activity in their elements. They are good conductor of heat and electricity. And now for the properties for D block elements, it have variable oxidation state, which we learned about also in S block elements. So it also shows color compounds, which means they absorb some sort of wavelength of light and they emit in a surface those color, different types of color. And they show catalytic activity. In case of iron, in the Haber process, they show the catalytic activity, and they have high melting and boiling points, and those are all those transition. That's why they are called the transition metal, because they show variable oxidation state and they show color compounds, and when they absorb some wavelength, then they show high melting and boiling point in case of their energy time, in case of some energy, high temperature. So this is for D block elements. We're gonna talk about F block element, which are inert transition element. They are soft metal mostly, and they present in the group lanthanides, which numbers is 57 to 71, and actinides, which number is 89 to 103. And those are the lanthanide and actinide series contain the F block elements. And this electron configuration for F block elements, it has the presence of F orbital. Here the electron configuration general form, and in n to the power 2, and F block it have a 1 to 4, that means 14 electron gonna present in the F block, and it has D and S. That means F block has S, P, D, F, all those. And here for the elements, lanthanum to lutetium, known for their rare earth properties, which is present in the lanthanide series, and actinium to lawrencium, are mostly radioactive. So lanthanide series are mostly earthy properties, and for actinide series, for actinium to lawrencium, it mostly are radioactive. And for the properties here, it shows multiple oxidation states that also present in other PDF blocks, PD block elements. So here it also shows multiple oxidation states, and they are highly reactive, which we will learn about that in the actinide series. In case of actinide series, they are highly reactive, and which spread actinium to lawrencium. And here actinides are mostly radioactive, which we learned there. Mostly the uranium and plutonium, they are the mostly radioactive elements in case of actinides. And then here lanthanides are mostly used in electronics, magnets, and phosphorus. Here for the F block elements and other, we learned today about SPDF block elements. And next class we're gonna learn one new thing, and that's for all. Thank you.